Okay, so this is a short video about the intermediate value theorem, and I'm calling it for pre-calculus because you revisit the intermediate value theorem when you get to Calc 1 and you look at it in a little bit of a different way. But for our purposes, we're visiting it when we're looking at polynomials. So this is when we're looking at it. So the intermediate value theorem for us, and if we're in section 4.2 of the book, I'm just going to read it to you, and then I'm going to draw a picture of what it means. It says that, let me find it. If p of x defines a polynomial function with only real coefficients, and if for real numbers a and b, the values p of a and p of b are opposite in sign, then there exists at least one real zero between between a and b. So this is on page 248 of your text if you want to read it. I'm going to explain it. So it says, if you've got some polynomial function, so we know what polynomial functions look like. They look like nice curvy lines like this. So we might have some polynomial function that looks like this. So let me find a different marker. Just 1 second. Okay, so some polynomial function. And so what it says is that if you can find that at some value a, so maybe this is a, and some value b, so maybe this is b, that p of a, or the y value that goes with a, and p of b, or the y value that goes with b, are opposite in sign, meaning one is negative, this would be negative, and one is positive. Then, because polynomials are continuous functions, and we don't have a big discontinuity anywhere, then it absolutely has to cross the zero line, so there must be a zero between x is a and x is b. That's basically what the theorem says. So, does it have to go from negative to positive? No, absolutely not. We can look over here. We can say, what if we have a polynomial function, and then we can find some x value for which the y value lands here, and this guy's positive. And then we can find some other value of x called b where the y value lands negative. If the y value changes from positive to negative between x is a and x is b, then somewhere on that interval between a and b there is going to be a zero crossing point because we're dealing with a continuous function. So that is what the theorem says. So now you have a couple of homework problems, which I have said, and I mean this, will not be on your test, but you do have homework on it. So this is how you'll get through your homework. Use the intermediate value theorem to show that p of x, a polynomial, has a real zero between the two numbers given. So, example 1, p of x is equal to 3x cubed plus 7x squared minus 4. This is a polynomial. It fits the bill. It's got real coefficients. The powers are non-negative whole numbers. So yes, this is a polynomial. We're going to show that there exists, we don't know exactly where, but we can show that there is one that lies between 0.5, which is 1/2, and 1. Now, we have learned how the remainder theorem, so I'm just going to use synthetic division 2 times to figure out the value of p of 0.5 instead of plugging it in. So, for example 1, I'm doing example 1. P of 0.5 is going to equal to whatever remainder I get when I run this through synthetic division. So, 0.5 is 1/2 is my value of c, which is 0.5. Put your coefficients up here, 3, 7. We don't have an x term, put a placeholder in, and -4. Do synthetic division. Bring down your 3. 3 times 1/2 is 3 over 2. Oh, dang. I thought these were going to not have to, I'm not going to have to fool with fractions. Darn it. Okay. This is going to be 14, 15, 16, 17 over 2. That's a 17 over 2. So then I multiply. 17 times 1/2 is 17 over 4. And then I add, and I get 17 over 4. And then I multiply. And 17 over 4 times 1/2 is going to be 17 over 8. So I'm adding 17 over 8 plus a negative 4 over 1. If I say times 8 times 8, I get a 17 over 8 minus 32 over 8. And so it's going to be a negative number. Okay? And so I don't care if you use your calculator, but it's a negative number. That's what we concluded. So I'm going to say negative number. You can figure out exactly what it is. Now, plug in 1. I'm going to do synthetic division, or we could do the 1, negative 1 test. The 1 test, P of 1, right? P of 1 is just when you add up the coefficients. So let's add these up. 3 plus 7 is 10, minus 4 is 6. The thing that I care about in this scenario is I plugged in 0.5 and I got a negative. I plugged in 1 and I got a positive. That means that the 0 exists somewhere between 1/2 and 1, because this is a polynomial. At one point we were at negative, and another point we're positive. Somewhere in between these two values there's a 0. That's how you apply this. So real quick, I'll do example 2. I will use synthetic division and the remainder theorem again, because I'm writing your test and I know that you have a question like that on it. So we did, for example 2, we got to show that a real 0 exists between 2 and 3. So we'll do, the remainder theorem says that P of 2 will equal to whatever the remainder is. And so here we go. To evaluate this polynomial for P of 2 using synthetic division, what you'll do is you'll write down the 2, and you'll put in the coefficients, -1, -1, 5, and 5. Bring it down, -1, multiply up, -2, add, multiply, add, multiply, add. This is 3, and this is positive. All right, let's try 3. P of 3 is going to equal to the remainder that I get when I run 3 through synthetic division. -1, -1, 5, and 5. Bring it down, -1. Multiply up, -3. Add, multiply, add, multiply, add, -16. -16. The fact that I got a negative result here when x was 2 and a positive result here when x was 3 means my function went at x is 2 to x is 3 from 3 to 16. It had to cross somewhere between here and here. There's a real 0. So that's basically the intermediate value theorem.